Hello and welcome back. We have finally reached the functional programming module, which is my favorite. Now I saw there was 3 or 4 people waiting. Oh, it already shows 3 people watching, so I'm glad some people are interested to go to this module. Now I would really appreciate if you would give a like, as YouTube will push this content to more people if there's some interaction on the video. So basically, last time we have reached the functional programming module, and this is where we're gonna continue from. So yeah, if you enjoyed this one, give a like, maybe subscribe if you're not subscribed, and let's get into it. So learn about functional programming. Functional programming is a style of programming where solutions are simple, isolated functions without any side effects outside of the function scope. Input, process, and then output. Functional programming is about isolated function. There is no dependence on the state of the program, which includes global variables that are subject to change. Pure functions, the same input always gives the same output, and functions with limited side effects. Any changes or mutation to the state of the program outside of the function are carefully controlled. And then they say the members of Freecodecamp happens to love T. In the code editor, the prepare T and get T functions are already defined for you. So they define some functions for us. I'm just going to check. Yeah, they define some functions for us. They prepare T and get T. And then they say call the getT function to get 40 cups of tea for the team and store them in the T4 team FCC variable. So here at the end we have a variable T4 team FCC, which has the value of null. And as you can see here, we have basically a function that when we call the function returns a string which says green tea. And then we have a function that gets the t based on the number of cups that you pass. And basically what it does, it creates an array t cups, and then it does a for loop from 1 to num of cups. It goes from 1 to num of cups, and basically it pushes that number of cups. It basically creates the t cup by preparing the t, and then it pushes it into the array, and then it returns the array with all the cups of tea. So here basically we have to call this function get tea with 40, right? Okay. Submit and go to next challenge. Okay, then they say understand functional programming terminology. The Freecodecamp team had a mood swing and now wants 2 types of tea, green tea and black tea. General fact, client mood swings are pretty common, obviously. With that information, we'll need to revisit the getT function from last challenge to handle various tea requests. We can modify getT to accept a function as a parameter to be able to change the type of tea it prepares. This makes getT more flexible and gives the programmer more control when client requests changes. But first let's cover some functional terminology. Callbacks are the functions that are slipped or passed into another function to decide the invocation of that function. You may have seen them passed to other methods, for example in filter. The callback function tells JavaScript the criteria for how to filter an array. So when we have an array like this, const numbers equals 1, 2, 3, 4, 5, 6, and for example we want to get only the even numbers in there, an array with only the even numbers, what we do is basically we filter numbers, and we have to pass a function to this method filter, which filter is basically a function, and we pass a callback method, which basically when that callback function returns true, then the number is added in the result array. So this function can take multiple parameters, but the first one would be each element one by one. So we get here number, well, we can give it any name, but basically it gets the element here, and then you can say number modulo 2 equals 0. So basically it returns all the numbers for which number modulo 2 equals 0, which means is even. So now if I run this, we get 246. So basically this function that we pass here is called a callback function. It's basically a function that you pass to another function. For example, if we say const get all even numbers, we make another function to exemplify what a callback function is, and this basically gets an array and then is even, which is basically a function, and we have to make this function is even, and basically is even gets a number. So is even gets a number and returns what it returns. It returns number modulo 2 equals 0. So basically if number modulo 2 equals 0, this returns true, otherwise it returns false, right? So now we can pass this function here, and here what we return, we need to get all the even numbers. So basically we return exactly like we did before. We return the array and we filter it, and we can pass to the filter, we can pass exactly this is even, right? Is even. Well, we in this context we already have it on here, so we don't really need to pass it, right? But let's say we call this just for an example to how you would use a callback function. So we call this is even, but we call this one even. So now when you say get all numbers and you pass an array like 1, 2, 3, 4, then you can pass this even function and it's going to be used here, right? Because you may get that function from somewhere else, right? So if I console log this, you can see it works. Basically we have passed it this function, which basically checks if a number is even, right? Now this is just an example of what a callback function is. A callback function is a function that you pass as an argument to another function, and it is used somehow in that function, right? Okay. Functions that can be assigned to a variable passed into another function or returned from another function, just like any other normal value are called first-class functions. In JavaScript, all functions are first-class functions. The functions that take a function as an argument or return a function as a return value are called higher order functions. So basically, if a function takes another function as an argument or it returns a function, then the function is called higher order function. When the functions are passed to another function or returned from another function, then these functions which gets passed in or returned can be called a lambda. This is something I didn't know. Now here it says prepare 27 cups of green tea and 13 cups of black tea and store them in T for green team FCC and team for black team Freecodecamp variables respectively. Note that the getT function has been modified, so it now takes a function as the first argument. The data, the number of cups of tea is supplied as the last argument. So as you can see here, we have a function which prepares the tea as green tea and one that prepares black tea. And here getT, now you pass it the function which prepares the tea and then the number of cups. So here when we want to get green tea, then basically we have to say get tea. We have to pass the function that makes the green tea, so prepare green tea, which will be used in here. So prepare green tea is gonna be prepare tea in here, so it's gonna prepare the green tea. So prepare green tea, and they want 27, right? And then here we want, and if you have any questions you can just ask them in the chat. Okay, so prepare black tea. Right, so we have green tea, green tea, green tea, green tea, and then we got another array with black tea, black tea, black tea, right? Okay, let's run the tests. Oh, here I left 27, I need to put 13. Alright. Okay, here it says understand the hazard of using imperative code. Functional programming is a good habit. It keeps your code easy to manage and saves you from sneaky bugs. But before we get there, let's look at an imperative approach to programming to highlight where you may have issues. In English and many other languages, the imperative tense is used to give commands. Similarly, an imperative style in programming is one that gives the computer a set of statements to perform a task. Often, the statements change the state of the program, like updating global variables. A classic example is writing a for loop that gives exact direction to iterate over indices of an array. In contrast, functional programming is a form of declarative programming. You tell the computer what you want done by calling a method or a function. JavaScript offers many predefined methods that handle common tasks, so you don't need to write out how the computer should perform them. For example, instead of using the for loop mentioned above, you should call the map method, which handles the details of iterating over an array. This helps to avoid semantic errors like off by one errors. Thank you very much for the like, much appreciated. Like off by one errors, like for example when instead of saying let I start from 0 going to less than length of the array, or you say from 0 but you go to the length of the array instead of going to the length of the array minus 1. So when you use for loops you might make those errors by mistake. When you use something like map, you won't be able to do those because map is already handled, they have it defined, they defined in themselves, so that's not gonna happen. Consider the scenario. You are browsing the web in your browser and want to track the tabs you have open. Let's try to model this using simple object-oriented code. A window object is made up of tabs and you usually have more than one window open. The titles of each open site in each window object is held in an array. After working in the browser, opening new tabs, merging windows, and closing tabs, you want to print the tabs that are still open. Closed tabs are removed from the array and new tabs for simplicity get added to the end of it. The code editor shows an implementation. So this code editor shows an implementation of this functionality, which functions for tab open, which basically opens a new tab and pushes it to the end of the array. Tab close, which removes a certain tab, and then join. Not sure what join does. Basically joins the tabs from two windows. The array tab is part of the window object that stores the name of the open pages. So here it says examine the code in the editor. So this editor, it's using a method that has side effects in the program causing incorrect behavior. The final list of open tabs stored in final tabs should be something like this, but the list produced by the code is slightly different. So here it says change window prototype tab close. So we need to change tab close so that it removes the correct tab. So basically tab close here has a mistake. Basically here what it does, I see it uses splice. Tabs before index equals this tab slice 0 index. Now the thing is, they ask us to do this before showing us how to use these methods. So they probably think we already know how to use these methods. So basically what it does is gets the tabs. It basically splices the tabs from 0 to index. Then the tabs after index. But this is not going to work because once you splice them, when you splice them, you basically splice the original array, and it's not going to have the same things in it. It's basically already changed. In this case, you want to basically slice from 0 to index, and then from index plus 1 to the last. So here you want to use slice, not splice, because slice just returns a new array while splice modifies the original array. I have a video on my channel, the difference between splice and slice. So if you want to look more into that, you should check it out. Right, this should work. So yeah, that was the problem. They was using splice. So basically when you use splice like this, you have an array const numbers equals 1 2 3 4 5. If you say something like const before, and you would say before this index maybe, and you say equals numbers splice, and you splice from 0 to 2, right? If you console log before, well, I can do that here. If you console log before, you can see you do get the 1 and 2, right? But now if you look at actually at numbers, that's modified as well. You only have 3 4 5 left. So if you say go from 0 to 2, and then you want to go after that from 2, const after equals numbers splice, and you want to go, as you can see here, it says from 0 to index, so from 0 to 2, and then from 2 plus 1 from 3. So you want to go from 3. What's gonna happen now is look at after. What does it get after? So basically this should get from here to here if it's by the logic, right? But it's not logical because it doesn't do what you expect it to do. So basically it gets an empty array because numbers it's already just 3 4 5. So if you want to get from 3, then there's nothing after 3, right? So what you want to do is slice, which slice basically just slices a portion, but it doesn't remove it from the array. It just slices and returns it. It doesn't remove it from the original array. So what you want to do here, if you use slice instead of splice, then that's gonna work, right? It's gonna return 4 5, and that one is gonna return 1 2 3 before. Yeah, there's a mistake here. All right, yeah, you actually just get 1 2 and 4 5 because this one you basically remove it, right? You remove the one other index. You don't make a space between them, you just take one out, the one at the index, right? All right, and I see somebody has said hello sir, and I want to say hello sir to you. How are you today? Thank you very much for joining. I hope you're getting some value from this. Okay, so here it says avoid mutations and side effects using functional programming. If you haven't already figured out, the issue in the previous challenge was with the splice call in tab close function. Unfortunately, splice changes the original array it's called on, so on the second call to it used a modified array and gave unexpected results. So when you use splice, the array was already modified. This is a small example of a much larger pattern. You call a function on a variable, array, or an object, and the function changes the variable or something in the object. One of the core principles of functional programming is to not change things. Changes lead to bugs. It's easier to prevent bugs knowing that your function don't change anything, including the function arguments or any global variable. The previous example didn't have any complicated operations, but the splice method changed the original array and resulted in a bug. Recall that in functional programming, changing or altering things is called a mutation, and the outcome is called a side effect. A function ideally should be a pure function, meaning that it does not cause any side effects. Let's try to master this discipline and not alter any variable or object in our code. So here it says fill in the code for the function incrementer, so it returns the value of the global variable fixed value increased by 1. So here we want to return this value increased by 1. So we could say something like return, and we want to, we could say maybe fixed value plus plus, because we want to increase it, and then return it, right? But if we do that, we actually change the global variable, and we don't want that. So what we want to do is just return fixed value plus 1, right? Okay, here it says pass arguments to avoid external dependence in a function. The last challenge was a step closer to functional programming principles, but there is still something missing. We didn't alter the global variable value, but the function incrementer would not work without the global variable fixed value being there. Another principle of functional programming is to always declare your dependencies explicitly. This means if a function depends on a variable or object being present, then pass that variable or object directly into the function as an argument. There are several good consequences from this principle. The function is easier to test, you know exactly what input it takes, and it won't depend on anything else in your program. This can give you more confidence when you alter, remove, or add new code. You would know what you can or cannot change, and you can see what the potential traps are. Finally, the functions will always produce the same output for the same set of inputs, no matter what part of the code executes it. Let's update the incrementer function to clearly declare its dependencies. Write the incrementer function so it takes an argument and then returns a result after increasing the value by 1. So here we want to get an argument, and we're going to say number, and we want to return number plus 1, right? So basically now we're using an argument, so it doesn't show here, but then we would say something like incrementer of fixed value if we wanted to return this value incremented by 1, right? All right. Here they say refactor global variables out of functions. So far we have seen two distinct principles for functional programming. Don't alter a variable or object, create new variables and objects and return them if need be from a function. Hint: using something like var new r equals rvar, where rvar is an array, will simply create a reference to the existing variable and not a copy. So changing a value in new r would change the value in rvar. So basically, if you have something like this, so you have a function const get evens, which gets array of numbers, and then let's say you somehow want to use splice on the array that you get, but you don't want to modify that original array, and you think you can do something like this. You think you can say const copy of array equals array of numbers, and then you can basically use slice on this. That's not going to happen, because what this does with arrays and objects, this only creates a reference which basically still points to that original array. If it's an array with just numbers, you could do something like this. You would create a new array and you would spread the contents. So if you spread the contents, then that's how you create the copy. But if you just do this, you just create a reference to the original array in this variable, right? Okay, so here it says declare function parameters. Any computation inside the function depends only on the arguments passed to the function and not on any global object or variable. Adding 1 to a number is not very exciting, but we can apply these principles when working with arrays or more complex objects. So here it says rewrite the code so the global array book list is not changed inside either function. The add function should add the given book name to the end of the array passed to it and return a new array list. The remove function should remove the given book name from the array passed to it. Both functions should return an array, and any new parameters should be added before the book name parameter. So instead of having this, where this function basically pushes directly into the book list, and it says here we want to add all the new parameters before the book name parameter. So instead of pushing directly into this, what we want to do is pass a list, which is an array, and here we don't want to say something like list push book name, because that will actually push in the original array. So what we want to do is we want to create a copy, const copy, right? And here you can do the way I did it before, where you basically you use the spread operator to spread the contents in there, right? And then you say copy push, and then you return the copy. Also, there's another way of doing it where you say, instead of spreading it, you can say something like list slice, and as we know, slice returns a new array, but since here we don't pass any indexes, then it returns the whole array but as a copy, right? So you can either do this or do the other one. So here we have created the copy, we're pushing the book name right at the end, and we return the copy. Here again we pass the list, and then here we say again the same thing, const copy equals list slice, then var book index equals copy index of book name. Then it checks if book index is higher than 0, because if it's -1 it means that book doesn't exist, and if it does exist we want to splice it out, right? So we basically say copy splice, and here we splice from book index 1. So basically we just remove that the book at that index. So basically here you give the index and you say okay, remove 1 from there, and then you return the copy, right? And let's run the tests, and that works. Alright, I was just checking. I'm just gonna check if there's any questions and we will go forward. Do let me know if you have any questions and I'll go back. Here it says use the map method to extract data from an array. So far we have learned to use pure functions to avoid side effects in a program. Also, we have seen the value in having a function only depend on its input arguments. This is only the beginning. As its name suggests, functional programming is centered around the theory of functions. It will make sense to be able to pass them as arguments to other functions and return a function from another function. Functions are considered first-class objects in JavaScript. We have already went to this, which means they can be used like any other object. They can be saved in variables, stored in an object, or passed as function arguments. Thank you very much for the like, much appreciated. Here says let's start with some simple array functions which are methods on the array object prototype. In this exercise we are looking at array prototype map, or more simply map. The map method iterates over each item in an array and returns a new array containing the result of calling the callback function on each element. It does this without mutating the original array. So it doesn't mutate the original array, it just returns a new array which is the same length, and each element is, it can be based on an element from the array it was called on, and we will give some examples in a bit. When the callback is used, it disposes 3 arguments. The first argument is the current element being processed. The second is the index of that element, and the third is the array upon which the map method was called. See below for an example using the map method on the users array to return a new array containing only the names of the users as elements. For simplicity, the example only uses the first argument of the callback. So here we have an array of objects, 3 three objects which have the properties name and age, and then you want to store just the names of these users. So basically you say users map, you get each element one by one and you return just the name, and this will return just the names of those users. So let's exemplify this a bit here to make it very clear. So as you can see here, it's an array of objects. Each object has a name property and an age property, and then we create a names variable, and to it we assign this array, but we're mapping through it. So basically we're saying, okay, we give it this array, which is the users array, but we map through it, and we get each element one by one. So this one first, then this one, and this one. So user will be one by one each element starting from beginning to the end, and you get user and you want to return just the username. So as you get the element one by one, instead of returning the element, if you would say here return user, then you would just return each element, right? But you want to return the username, and that will return just the name, right? So then at the end we would just have an array with the value of the names. Now as it was saying here, this callback actually can get an index as well, which is the index of the element in the array, and it also can get an R, which is basically the array is called on if you want to use it inside here, right? To say array length or something like that. All right. Okay. So here it says the watch list array holds objects. Now if you have problem with map and you don't really understand map, you have any questions about it, let me know and I'll try to explain it better, because I know some people at the beginning struggle understanding these methods. The watch list array holds objects with information on several movies. So we have an array watch list that holds information on several movies. And they say use map on watch list to assign a new array of objects with only title and rating keys to the ratings variable. The code in the editor currently uses a for loop to do this, so you should replace the loop functionality with your map expression. So as you can see, we have a watch list, which is basically an array of big objects. We have some big objects in here with many properties, right? And then here what it does is basically create a new array, and then it loops with a for from I0 to watch list length, right? And basically it pushes into rating a new object, which is basically the title is basically watch list of I of title, and then rating is watch list of I IMDb rating, right? Now this is much simpler using map. The way you do this with map, you basically say ratings equals to watch list, then you map watch list dot map, right? So this is the method. You get each element of the array in argument in the argument movie, right? Or you can give it any name, right? You just know is the each element one by one, and what you want to return instead is another object that is basically movie. So movie is the element you want to get movie. So title will be movie title, movie dot title. I think title here we need with uppercase, and then you have IMDb rating will be movie dot IMDb rating. right? And we can just delete this. So very simply, we just have something like that. Am I doing something wrong here? But basically here, because we are returning immediately, you want to either say something like this. You put another object in here, and here you say return, and you return this object, or basically you can just take this off, take the return off, because it only returns one thing, but you want to put this between parentheses like this, right? So you're returning a new object which only has the title and the IMDb rating, right? Now here's the thing, there's one thing that's called destructuring, where if you have an object like this, const user equal, and you have an object and you have name Marian, and then you have age 32, if you want to get the name of this user into a variable name, you can just say something like this. You basically destructure it, you say const name equals to user, and this basically creates a variable that is called name, which deconstruct exactly this property from the object, right? So if I would to console log name now, we would get Marian. And this destructuring thing, you can actually use it when you have an element in here. So instead of, thank you very much for the like, much appreciated. So this movie element, which is basically, this movie element is basically each of these objects one by one, and you can actually, because it's an object, you can actually do this and deconstruct properties from it. You have different properties, and all these properties you can destructure them. So here I can destructure title, and I can destructure IMDb rating, because this is the only thing I need. And now I can say title is title, and then IMDb rating is IMDb rating. And the final thing, in JavaScript, I don't know how it's called, but if the name of the property and the value you give it has the same name, like title and IMDb rating, and you give it a variable that's called IMDb rating, then you can just say once. You can just say it once and once. And basically what this says is, to the property title, give it the value of a variable that's called title, and to the property IMDb rating, give it the value of the variable that's called IMDb rating, right? So now we just do this, right? So if I copy this here, you can see, going back to how it was before, if I reset our code, reset this lesson, you can see how it was looking before, pretty ugly with all these things, and now you can just have something much nicer, right? Okay, so let's run the tests. Okay, what is the problem? It says that the title and rating keys, a new array with only title and rating keys to the ratings variable. Oh, I don't okay, so maybe it just wants to have title and rating, like these small ones. So if that's the case, then we can just do the thing, but anyway, I simplify this. You can just say title is title, and then rating is IMDb rating, right? And that's it. Okay, now here it says implement map on a prototype. As you have seen from applying array prototype map or simply map earlier, the map method returns an array of the same length as the one it was called on. It also doesn't alter the original array as long as its callback function doesn't. So basically it says it does not modify the original array as long as this function that we pass doesn't, because This could actually modify the original array if when you get here, because like we say, we can get the element, we can get the index, and then you can get the original array like R. So inside this callback function, you could actually access that array and modify it, or just modify the original array, right? You could actually do something in this function before returning that modifies the original array, but usually you shouldn't really do that. Okay, so here it says, in other words, map is a pure function and its output depends solely on its inputs. Plus it takes another function as its argument. You might learn a lot about the map method if you implement your own version of it. It is recommended you use a for loop or array prototype for each. So here it says, write your own array prototype map, which should behave exactly like array prototype map. You should not use the built-in map method. The array instance can be accessed in the myMap method using this. So this is how you write. Basically, if you want to add a method on a prototype like an array, so basically if you want to add a method, like we have the map method that can be called on any array that you have in your program, you can add your own methods by saying something like array prototype, and then you give it a name, and then you have a function, right, which takes I don't know why it uses this callback. Oh yeah, basically it takes a callback function, right? And then it does something, right? Now here's the thing, it's not really recommended to add methods on the prototype. It's better to extend this prototype and add to that extended version of the prototype, because if in the future there are more methods added by the JavaScript team or whatever on there, you can actually mess up some of those functions because you already named them. I mean, you could give them some unique names, I guess, and you can do it, which is pretty useful sometimes, but I leave that up to you. So here they just says that they want us to basically make our own version of map, and to do that, basically, you see how we say my map equals a function which takes a callback, which is basically in a map you give it a callback, right, which basically calls that function on each element, right? So here what we want to say is we can use for each, for example, and say new array for each, and actually we say what is a new array equals empty array. Yeah, so we create a new array which is empty, right? And then we can actually access, like they said, we can access the array that this method will be called on by using this. So when we will use on the array the method, like we have an array called numbers, and we call what is going on here, we called my map on it after we put it on the prototype. Then we can access the value, like we can access this array in here by using this. This is basically what it has been called on. So what we want to say is this for each, we're going to use the for each method, which is another method, or we could use a for loop, right? But I'm going to use for each for this, and maybe after that I can do it with the for as well, but we're going to use this for each, and we're going to say for each element we want to say new array push. We're going to push, so we get each element one by one, and in the new array we basically push callback. We push basically callback called with the element, right? because basically this is what a map does. You give it a function, and map returns a new array by calling each element with that function, right? So we're basically pushing here each element called with the callback, right? So we call back each element and we push it in there, right? And we return the new array, right? So let's copy this here. And this works, as you can see. Now this is the same as saying something like for let I equals 0, I less than this length, and then I plus plus, and then we say new array push, and we push callback of this of I, right? So it's the same as using for each, only with for. Okay. Alright. Here it says use the filter method to extract data from an array. Another useful array function is array prototype filter, or simply filter. Filter calls a function on each element of an array and returns a new array containing only the elements for which that function returns true. In other words, it filters the array based on the function passed to it. Like map, it does this without needing to modify the original array. So filter will not modify the original array, it will return a new one with only the elements that pass the condition. So which returns true for that condition, right? The callback function accepts 3 arguments, so it's the same like map. The first argument is the current element being processed, the second is the index of that element, and the third is the array upon which the filter method was called. See below for an example of using the filter method on the user's array to return a new array containing only the users under the age of 30. For simplicity, the example only uses the first argument of the callback. So we have an array of objects, and we say const user under 30 equals to users filter, and basically we have the callback function taking each element one by one, and it basically says return user age less than 30. So basically when we get the element and user age less than 30 is actually true, so when this is true, so the function will return true, then that particular element will be added to the array that is returned, the filter array, right? So let's exemplify this here again. So you have this, and basically what it does, it takes this one, it takes this element first in user and says user age less than 30. This returns false, so this will not be put in this array. So this will not be put. Then it takes this one and says user age is less than 30. Now user age is less than 30 in this case is true, so we will return true. So this element will be right, will be added in this new array. Then it takes this element and does the same, and this will return true because 10 is less than 30, so we will add this one as well. So this will return the users under 30, will return these two, an array with these two, and we have clear, and I didn't save this, and we get these two, right? Let's put another example just to make it clear. If I say here const numbers equals 1, 2, 3, 4, 5, as you can see, if I make this function actually return true, right, you will see that all the numbers from the original array will be in the result array. Users is not defined. So here I need to put numbers. Okay, so as you can see, because I returned true for each element, all of the elements were added, so nothing was filtered because it was returning true all the time. If I return false, then it will be an empty array because it returns false all the time. If I say, I'm gonna change this to numbers to make it more clear. If I return number modulo 2 equals to 0, then this will be true only for the even numbers, so we filter just the even numbers and so on, right? This is how it works. Higher than 4, right? And we will get only the ones higher than 4. Alright, it says here the variable watchlist holds an array of objects with information on several movies. Use a combination of filter and map on watchlist to assign a new array of objects with only title and rating keys. The new array should only include objects where IMDb rating is greater than or equal to 8.0. Note that the rating values are saved as strings in the object and you may need to convert them into numbers to perform mathematical operations on them. Right? So basically we need to change it so it only has the title and the rating, and we want only the movies that have a rating higher than 8, right? So what we want to say, var filter list equal to watchlist, and maybe we filter first. We want to filter movie, and we want to say, because it says the rating is as a string, so we want to make it a number. So we want to say we can use the number, and we say number of movie rating is higher than 8, higher or equal to 8, right? So if this returns true, then the object is actually added in the copied array, right? And then we want to map through this. After we filter, we want to map, and we want to again say movie, and we want to return just the title, which will be the movie title, and then the rating. And here we said movie rating, but we want to say movie IMDb rating because that's how it's stored, right? And here we said title will be movie title, and rating will be movie IMDb rating. And the title is actually title with a big T, like this, right? So let's run the tests, and that is it. Okay, and we get praise from Bucur Ion Nicolae. Thank you very much, Ion. Mersi mult. Cred că aici ne oprim azi și probabil voi mai face unul poi mâine. Oh, started talking in Romanian. Ion, you make me start talking in Romanian. So yeah, we are stopping here today because we actually went through a little bit of functional programming. We went to the map method and we went to the filter method. So we don't want to overload if anybody is new to JavaScript. We'll do another one in about 2 days. I hope you learned something from this one. If you have any questions about JavaScript, do keep them for me and ask me anytime. Thank you very much, and I'll see you next time. Bye bye for now.